This video is going to look at our first addition reaction, which is hydrogenation. We're going to start by asking, what is hydrogenation? As the name implies, hydrogenation involves the addition of hydrogen across a double bond. In an addition reaction, our reactants will be either alkenes or alkynes. So our reactants will be unsaturated with a reactive double or triple bond. We're going to add hydrogen to our reaction, and we will often need a catalyst of some sort, and we'll talk about that in just a minute. So when we say adding across the double bond, what we mean is that that double bond is going to essentially break and allow each carbon on either side to form two new bonds. So our hydrogens from each two end up on our molecule. The catalysts in these reactions are typically solid metals. Usually you'll see palladium or nickel as a catalyst. The first example we're going to look at is the hydrogenation of propene. So I've drawn propene here, and I've added our hydrogen gas. I've written it as HH just so it's a little bit more clear where everything is going. This is going to take place in the presence of a catalyst. So we write catalysts just over the reaction arrow. When this reaction takes place, each hydrogen will bond to one of the carbons on either side of the double bond. Because carbon can only form 4 bonds, when 2 new bonds are added, one of the existing bonds on each carbon must break. This is going to be the highly reactive double bond. When this double bond breaks, we're going to form an alkane. So we'll get rid of our double bond entirely. So we still have all of our original atoms. Nothing is being removed, unlike in an elimination reaction. However, now we have 2 new hydrogen atoms added to our molecule. And our molecular product is propane. The next example we're going to look at is the hydrogenation of 3-methyl-but-1-ine. This time we have a triple bond instead of a double bond. A triple bond is going to require 2 moles of hydrogen gas to fully react and form an alkane. If we react only 1 mole of hydrogen, we will get rid of only 1 bond. So when 1 mole of hydrogen is reacted, and we'll highlight these hydrogens in green, we end up with our original compound. Now we have a double bond with the carbon and 2 new hydrogens from the hydrogen we added. If we add a second mole of hydrogen gas, and we'll highlight this hydrogen gas in yellow, we'll end up with an alkane. So we have our green hydrogens from our first hydrogenation and our yellow hydrogens from the second. A general rule of thumb is you need 1 hydrogen for every double bond and 2 hydrogens for every triple bond.